Yes, now we can continue the continuation of the previous session. In the previous session, we had discussed up to the requirements of the self-healing grids. Now we can discuss the requirements of the self-healing grids. Right. So under the requirements of self-healing grids, the first one is the system topology representation. Under this, the system topology representation means feeders with a single restoration path generally open for the tie switches. Then the pre-fault system status. Under the pre-fault system status, switch status, that is the upstream and downstream information for the device, that is incoming and outgoing devices. Yes. Next is the pre-fault system loading. In this, the meaning of this one is capacity check for the restoration. How the systems could be restoration could be carried out. What is the maximum capacity of the restoration process? Right. Then the fault detection. So based on the reclosure lockout status and the reclosing counter value change or a substation breaker trip signals. So based on this, the fault could be detected. Then now the next one is a downstream mode for the lockout switches is a fault location. Right. So under the fault isolation, next one is fault isolation. Under this, there is the downstream switches of the fault location. Next is a load restoration. So under the load restoration, it starts from the downstream mode of the isolation switches. Then next one is the benefits. What are all the benefits regarding this one? So the benefits, the first one is allows the utility to focus investment on the feeder that experience the most outages. Right, most of the outages could be experienced and then it could be focused for the investments, and then fast implementation and initial low capital investments. And next one is a target solution appropriate for the problem feeders. So these are all the benefits of this smart grids. So next heading is a smart grid and its needs. So needs of the smart grids. So under this, a smart grid is an electrical network that can be intelligently integrate the actions of all users, right? So of all users connected to it. So it can interconnect and intelligently it could activate among the all users, right? So that is the generator, consumers, and those that do both in order to efficiently deliver sustainable economic and the secure electricity supplies. So under this, the first one is system, that is generation, transmission, distribution with an advanced two-way communication system, which has been done with the help of smart grid with the communication networks. Next one is which enables the real-time monitoring of the and controls. Real-time monitoring which could be done with the help of the SCADA systems. Next one is provide the great visibility and the transparency. And next one is consequently enables cost reduction and then efficiency improvements. And under the smart grid is based on the digital topology that is used to supply electricity to the consumers via the two-way digital communication. These systems allows for a monitoring. The same thing which could be intelligently monitored with the help of this communication network by the smart grids. Next one. So regarding the needs, we can see that a smart grid distribution system whose objective is to develop the power grid more efficient and reliable, improving the safety and the quality of the supply in accordance with the requirements of the digital age. Right. So the first one is the higher penetration of the renewable resource or a distributed generation. Next one is the extensive and effective communication overlay from the generation to the consumers. Next one is the use of advanced sensors and high-speed controls with this smart grids, and then higher operating efficiency, and then greater resiliency against the attacks of the natural disasters, and automated meterings and repair power restorations, which could be also done in an intelligent manner with the help of the smart grids, as well as provides a greater customer participations. So these are the needs of the smart grids. And then presently, an Indian electricity system faces a number of challenges such as shortage of power, power thefts, poor access to the electricity in a rural areas, huge loss in grids, and the inefficient power consumption and the poor reliabilities. To overcome this problem, smart grid is needed. So these are the challenges faced by this electricity. So to overcome this, we can move on to the smart grid. Next one is benefits of the smart grids. What are the benefits? With the help of the smart grid, what are the benefits could be achieved? First one is self-healing. Self-healing means, as we discussed earlier, it could be automatically, it could identify the fault and rectify the fault and do the economy operations. So the smart grid automatically detects and responds to the routine problem and quickly recovers if they occur, minimizing the downtime and the financial losses. So the downtime as well as the financial losses could be minimized. Then resist attack. It means a smart grid has security built in from the ground ups, and then motivates and includes the customers. A smart grid gives all consumers, industrial, commercial, and residential, visibility into real time pricing and offered them the opportunity to choose the volume of consumptions and a price that best suits their needs. Next one is reduction in AT&C losses and reduction in CO2 emissions and enabling energy audits and reduction in cost billings and remote load controls and shifting of peak requirements to the non-peak times, and then integration of renewable energies and clean energy developments, and which provides the power quality. These are all the major benefits of the smart grids. Next one, we can discuss the function of a smart grid components. So regarding the function of smart grids, the area of application of a smart grid includes the smart metering, integration, demand management, smart integrations of the generator energy, administration of storage and the renewable sources, using the system that continuously provides this and use the data from energy networks. And then smart device interface components. Next one is in the smart device, the monitoring and control from part of a generation components, real-time information process. And this could be achieved by these resources need to be seamlessly integrated in the operation of both centrally distributed as well as the district energy systems by the smart devices interface components and then storage components. So due to the variability of the renewable energy and then disjoint break peak availability and peak consumption, it is important to find a way to store the energy generated energy for a later uses. So the option of energy storage technologies includes the pumped hydro advanced batteries and flow batteries, compressed airs, superconducting magnetic energy storage, supercapacitors and flywheels. This comes under the storage components. And then transmission subsystem components. The transmission system that interconnects all major substation and load centers is the backbone for an integrated power system. These transmission lines must tolerate these dynamic changes in the load contingencies. Then smart grid driver. These are one of the important heading. So under the smart grid drivers, first one is the increasing demand, which is also one of the smart grid, which tells that implies that information and the communication technology, measurement and controlled demand response, and advanced metering infrastructure, that is AMI, which implies the increasing demands. Then next one is a high aggregate technical and non-technical losses, which is of 18% to 62%. Then aging assets, that is transformers and feeders, etc. And grid to carry more power. So needs for reliability and greater security. Billing and collections. So in this profitability of distribution companies, then energy mix, need for renewable energy, hydro power and solar thermal energy, wind, biomass and biogas. This has to be reduce the carbon footprints. So these are all about the smart grid in the brief. So in detail we can refer the books. So next is evolution of a smart grid. So under the evolution for the metering, transmission grid and distribution network, elementary stage, there is the evolutionary stage and fully integrated smart grid stage. In the elementary stage under the metering, large manual metering, some automated meter for large industries. But in evolutionary stage, see 100% smart metering with the automated meter reading with the real-time displays. But for fully integrated systems, advanced metering allows real-time rate change as well as the remote on-off capacity. For the transmission, zero automation in the transmission and switching and substations, ongoing automation HV system substations for evolutionary stage, and for fully integrated stage, the fully automations of HV systems and substations, all switches and the flow remote controlled. Then distribution network. Under the elementary stage, there is zero automation distribution network including the substation and circuit breaker, manual fault isolation. But evolutionary stage, partly automated switches, circuit breakers along the ME lines for fault identifications, and manual LV grids. But in a case of integrated smarts, fully remotely automated distribution networks with the remote sensing and the voltage control capacity. That is about the smart grid evolution. Next, we can see the comparison between the smart grid and the conventional grid. This is also one of the important topics. Right. So under the smart grid, more or less there is a 12 points. You can go through this in detail. You can discuss. You can analyze in the books also. I'll give the hints. That is self-healing for a smart grid, for conventional manual restoration, and for smart grid digital, it is an electromechanical. This is a passive controls and limited controls, two-way communication, one-way communication for the conventional. This is a distributed generation, centralized generation for conventional. In smart grid networks, it is a hierarchical. In smart grid, adaptive and islanding, failures and blackouts will be happened in the conventional. And sensors throughout. In the conventional, there will be only few sensors. In a smart grid, remote check and tests. But in a case of conventional, what is a manual check and test is available. For a smart grid, self-monitoring. But in a case of conventional, it is a blind. And many customer choice, only the few customer choice. But in a case of smart grid, extensive real-time monitoring. But in a case of conventional, lack of real-time monitoring. Right. So this is a basic comparison of a conventional and a smart grid technologies. Right. Remaining we can discuss in the next session.